are so many issues that can happen with your data, like schema changes that are triggered by engineers, not even folks on the data team. Unknown unknowns are things that you can't really predict for, and you didn't know to set tests for. So in terms of solving for those, we really encourage folks to lean on more automated processes.
Hello, everyone. Thank you so much for joining our book club chat this month. We're very fortunate to have Molly joining us to talk about her brand new book. Oh, it's not showing up. Data Quality Fundamentals. Yep.
There we go.
Okay. Awesome. Thank you. Let's get started with a round of introduction and we'll dive right into the book.
My name is Molly Vorwerk. I'm head of content and communications at Monte Carlo, which is a data observability company. And what that means is we help data engineers and analysts and scientists understand the health of their data through anomaly detection, field level lineage, and a bunch of other tools to help improve data reliability. So prior to this, I worked at Uber. I managed their engineering blog and their technical brand program. So I worked with engineers and data scientists to help them write and communicate about what they were working on. So super excited to be here to talk about the book. Thank you for having me, Sophia.
Thank you so much. Daniel, would you like to go next?
Yeah, sure. My name is Daniel. I have been working for quite some time, like 17, 18 years. I work at CITI. It's a Research and Development Institute in Brazil, and I have been working with data in the last 1 year and a half. I'm an engineering manager, and I manage a data team. So I'm super interested in this book club because we read so many interesting stuff, and it's very nice to be able to talk with people that are so knowledgeable, like the other authors and like you, Molly. So I'm very pleased to be here and very grateful to be able to chat with you. Thank you.
It's actually Daniel's idea to read about this book because he was working on data quality, data reliability issues at his own job, right? That's why you really wanted to read this book.
Oh, that's fantastic. I'd be curious to hear what specific issues, I guess how you came across it and what specific issues you were dealing with.
It's not like issues. I mean, I've joined this team recently, and I have software engineering background. And when I go to a data team and I see all the stuff that we have on the software engineering side and where the data teams are, I just, there must be a lot of new things, we have okay, unit testing. How do I do unit testing data, and how can I find more stuff about quality? I mean, it's not okay, we're having lots of data downtimes and my project's a mess. No, it's not like that. It's like that. I have this.
It's good to be proactive. It's good to be proactive.
Yeah, I have this internal thing okay, let's try to be excellent. Let's try to be better. And I don't know, I think data quality is a topic that it doesn't get a lot of talk, and I think it's true because people make decisions using data that sometimes is not good data, and I don't know.
It doesn't get enough respect.
Yeah.
Completely. So that just kind of goes with my first question. What's your motivation of writing this book? And is it from your past experience working with companies, and what's your experience seeing what others are doing in terms of data quality control and building a reliability system?
Yeah, that's a great question. And so obviously I don't want to speak too much for the other authors, but this was a joint effort between myself, Bar Moses, our CEO, and our co-founder, Monte Carlo, Liorgevich. So they, prior to founding Monte Carlo, worked on teams where data quality kind of was a consistent issue, and they would be surfacing dashboards and reports to customers or internal consumers of the data. And, they would be getting slacks like, the data is wrong, what's going on? Why can't I trust this? And so it inspired them to kind of launch Monte Carlo and create the data observability category and a product that's serves this. But simultaneously, Bar was writing a lot about her experiences with this issue, and she posted to towards data science Medium channel about the rise of data downtime and how this was a serious problem for companies that were trying to become more data driven and make decisions based on data. And if the data isn't accurate, you can't really do that, and you lose trust. Trust is way easier to lose than it is to gain, and that was something that she experienced firsthand during her time at Gainsight. And likewise, Lior was at Barracuda, which is a security kind of a security software company, dealing with similar issues. And so when Bar was kind of writing these articles, she was talking to hundreds of data practitioners about their experiences. And time and again, this problem of data downtime came up, and data quality kind of really is the root of it all. And then for my own experience, I was at Uber before this, and I would work with engineers to kind of write about the technologies that they were working on. And data quality was something that came up a lot, like technical solutions to solve the problem of data quality. So we created a homegrown anomaly detection tool that we developed in-house and scaled across the company. We had dedicated data product managers that were responsible for data quality, and it was just a problem that teams across the company were facing. And so O'Reilly actually reached out to us to write this book. And based on my experience, Lior and Bar's experience, we were like, well, yes, of course, this makes a lot of sense that they would want someone to write this book. And so we partnered with another person on our team, Ryan Kearns, who is a data scientist at Monte Carlo now, but at the time he was kind of he was a student at Stanford who was actually working on this problem, and kind of the intersection of data and philosophy and data reliability and trust came up a lot in his research. And so he's actually responsible for building some of our anomaly detectors at Monte Carlo. So he partnered with us on the book, and we also interviewed tons and tons of practitioners, whether they were customers or just folks in the field who had spoken to us about data downtime. And so we were able to kind of piece together this narrative and different technical approaches and technical processes that data practitioners can use to actually start being serious about data quality or thinking more intentionally about how to solve it.
Love it. Thank you. Do you think it's more of a data engineering issue or data science issue, or is end to end, everyone need to be aware of this data quality, data reliability?
That's a really good question, and something that comes up a lot, and we address very early on in the book. So actually, before we wrote the book, Bar and I wrote this article about the RACI matrix of data personas. So a RACI matrix is a matrix that kind of tells you for any given task who's responsible, who's accountable, who's consulted, and who's informed. And data quality is something that affects so many different people at the company. And when you're talking about actually being the person to own data quality and to solve it, it really depends on your organization and how your organization, I guess, handles data. I know, Daniel, you mentioned that you kind of have more of a software engineering background. And so a lot of people who come to data with that perspective and with that experience tend to think of data quality as a data engineering problem, because data quality is something that impacts systems at scale, and you can kind of apply a DevOps approach, or they call it, I guess, data ops approach to managing it. But there are other companies that have a very data science heavy team. And so the way that they think about data quality is a little more focused on okay, we have a few critical data sets. We really need to make sure that the data in these data sets is accurate, and that, it doesn't inform our ML models or anything like that without ensuring that the data is reliable. So we kind of see it coming from both angles. I would say probably about 80% of the folks that I've spoken to over the past 2 years, and this is hundreds of data teams, do think of data quality as more of a data engineering problem. And the data scientists are more focused on data cleaning and data data wrangling and kind of like making sure that the specific data is reliable before you put it into the system. Whereas data engineers are like, okay, we need to make sure that data in production is reliable because it's fueling all of these disparate products. So that's kind of the perspective that we took, and that's kind of what we've seen in the field.
I think that makes a lot of sense. I mean, as a data scientist, I care about data a lot, but like, where is the data from? What's the root source of the data?
Yeah.
That's kind of in the data engineering side. Although even though we need to understand how the data is passing through different APIs and stuff, we're not actually working with that and monitor that process closely.
Exactly,
Yeah,
but yeah.
Yeah, I feel just like with software engineering, I mean, you don't say like, okay, the responsible for quality is the test team, maybe the data science, when they're doing their exploratory data analysis, they're going to check, okay, this data is really strange. Why we did not detect that earlier? And maybe the data engineering team kind of create some kind of test with an expectation. Okay, this data should have been alert, right? Or freshness, like you told, okay, this data is stale, or also volume, like, I mean, okay, we receive hundreds of rows every day, and today we receive only 10. I mean, so yeah, I can see, as you told, like everyone's responsibility. I mean, in the end of the day, it's not only like creating data ops stuff, but it's also not only on the exploratory analysis side. I mean, I think everyone is responsible. I mean, and
exactly, yeah. And kind of what we found when we were doing our research is that data scientists are very concerned with the field health and the field distribution. So like what is kind of in the, what should the data be looking like based on what's feeding it? But the data engineering teams are the ones who are actually building the infrastructure that supports the data products and the dashboards and things like that. So it kind of depends where the data quality issue is coming from. If it's more like a metrics focused thing, it's probably the data scientist is the one who, is on the line. But if it's something where it's like, oh, our pipeline broke, or, oh, we have a freshness anomaly, it's often the data engineering team that's responsible.
Speaking of data quality, all the tests we're doing to ensure the data quality, the book has mentioned that the traditional tests are hard to scale, and we need to manually set up all the tests. And when we write tests, we only test for like, I think the word is known unknowns. That's in the book. And there are like a lot more unknown unknowns. What's your advice or suggestion on how to deal with the unknown unknowns and how to scale better to build a better data quality system?
Yeah, that makes a lot of sense. I mean, that's a good question. I think that so known unknowns are things that you can predict. And so for instance, it might be like null values, or, hey, I know that this data set needs to be within 50 to 1,000, like the values need to be within 50 to 1,000 or whatever it is, or I know that the values need to be in CST or Fahrenheit. But there are so many issues that can happen with your data, like schema changes that are triggered by engineers, not even folks on the data team. There could be like volume anomalies that are affected by like issues with, the APIs feeding data. There could be issues kind of with the operational flow of the data platform, like let's say your compute costs are way out of, off the rails. And that's something that affects kind of like, can affect downstream sources. So unknown unknowns are things that you can't really predict for, and you didn't know to set tests for. So in terms of solving for those, we really encourage folks to lean on more automated processes. So there's something called a circuit breaker, which you can actually do within Airflow. It will actually kind of trigger should there be, and you can, it's like part of the open source Airflow framework, and you can find it on their docs and all that stuff, but it actually can kind of stop a pipeline for running if there's an issue that you we've kind of pre-configured. The one kind of downside to doing all of this manually is that it takes time and resources. And so we really encourage folks to think about this from like an automated perspective, like ways that you can automate things, whether that's integrating Python with your existing like DBT or Great Expectation tests, or it's investing in something like a data observability solution or a data anomaly detector or something like that. So the more you can automate and the more you can kind of ensure that you're focused on the data, like you know what tests to run because those are important and you know what to expect. But when it comes to solving for the unknown unknowns, it's really valuable to kind of lean into automation and more data ops processes.
That's a great point. And the book also mentioned like when you have those automated processes to check your issues, there could be a lot of alerts, right?
Yes.
And people can
yes.
get lots of alerts and they just like don't care about them anymore. So
Yeah.
how do you deal with the issue where
The boy who cried
people
wolf,
get too
right?
many?
Yes, the boy who cried wolf. Yeah. Or girl who cried wolf. Yeah. So one way to deal with that is by grouping alerts. So if you have like 10 alerts that go off within 5 minutes of each other, you can group them because they're probably related to each other. And that's one way. And then grouping the alerts and sending the notifications to Slack or email or wherever you check for those. Another thing that you can do is do a bit of, so one thing that automated observability solutions can do out of the box is train on historical data to understand like what looks good and what looks bad or off, I guess. But if you were to do this manually, there are various ways that you can train your anomaly detectors, kind of using different frameworks and tools, and we list several of them in the book. For I think, PySpark is one of them, MLflow. There are different open source tools that you can use to help train your anomaly detectors over time. And again, it does take time and it does take effort from your team, but I would say grouping alerts, training your detectors, as well as kind of setting up only the detectors that you actually need for the data that's more critical. That's another thing that you can do.
That makes sense. Thank you. Daniel, do you have more questions?
Yeah. I mean, I've been thinking about like we create lots of alerts and sometimes we find stuff but sometimes the problem is not from the data engineering team, right? Sometimes it's something that go all the way through the search systems. So I don't know. My feeling is that I don't know if we have some kind of decision framework. I mean, okay, I got this error. What should I do now? Sometimes it seems like simple. I don't know. I have these IoT devices that keep sending like temperature, and one temperature is completely off, and then you say, okay, I can just discard that. It will not have any effect. But I don't know. Sometimes it's very difficult to know. Okay, there was an error. What do I do now? I mean, is this a problem from the search systems? Will it continue happening? I mean, should I put this data on quarantine or something like that? So I don't know if you guys have any experience or advice, or if your platform have some kind of decision making for that.
Yeah. So one thing that teams can do is, and I'm sure this will be familiar to you because you have a software engineering background, but applying principles of like site reliability and DevOps to handling some of these problems. And so by that, I mean, putting together like a strategic incident management framework. As you mentioned, a lot of these alerts are not actually issues. Maybe it's like an expected schema change, but it triggers an alert. And then that, if you don't know that was expected, then people can unnecessarily freak out or spin cycles trying to solve a problem that isn't actually a problem. And so what you can do is you can actually, if you do group your alerts and you kind of put together a framework for solving these problems, you can set up alerts such that you can kind of put together a system for saying whether or not the alert is actually something to care about. So a lot of things something that a lot of DevOps teams do is they have dedicated emojis in Slack or in Teams or whatever to indicate like, okay, this is actually a Sev 1, or okay, this is like a Sev 5, like we don't actually need to look at this. And there is some manual effort to kind of putting something like this up. And we actually have an anecdote about the data team at Red Ventures, who is putting together kind of like an SLA framework for different issues that surface. And it does take a lot of time and a lot of training, but it really is effective, and you can scale it quite quickly. And then it can be very meaningful and save time and resources over time. So one way to do that is putting together like an incident management process, as I mentioned, with like SLAs, which are service level agreements, basically saying like, okay, if the data is if we have like a row that has or if we have a table that has 50 rows, but it suddenly goes to 50,000, like that's something that we should look at, and we should look at it within this amount of time, and let the stakeholders know who need to know. And then there's service level objectives, which are kind of like I would say the kind of the quantifiable way of measuring SLAs. So it's like, okay, here's the objective. So that would be the number that we're going after for the amount of rows. And then indicators or signals that will tell us whether or not something looks off. So tracking those. And then I would just say another way of doing this is also kind of putting together and not doing this, but learning on the job, is putting together kind of a process of blameless postmortem. So like understanding like, okay, something did break, here's what we're going to do and learn from next time. It could be that we spun our cycles on something that isn't actually an issue. So we're going to kind of train our detector or kind of like mute that alert when it comes up again, because it's really just a schema change. And so something that you can do with data observability or most data quality monitoring tools, whether you build them in-house or purchase them off the shelf, is muting white noise, or saying like, okay, there's a schema change on this table, this isn't actually an alert, so next time it won't bug the team. So those are a few things that you can do.
Great, that they're all in the book. I was just
yes, yeah,
thinking about how to put them together. Okay,
yeah.
So I feel like sorry, Daniel, do you have another question?
Oh yeah, but my question is on another subject, so you can
mine
go.
too. You go ahead.
Yeah, I was thinking just about a data catalog.
Yes.
Because I mean, from what I see, it's kind of a documentation of the data that you have, of the features and all this stuff. And I believe it was like all done manually. Okay, I'm gonna provide that data to my data science. It has feature A, B, C, and I'm gonna explain everything.
Yeah.
And you mentioned about data discovery, which would be some kind of automated way of doing that. And it kind of really merges with the data lineage, the field level lineage that you guys mentioned. So I don't know, I was wondering if you can explain like more about that, if you have some kind of example where this data discovery, I mean, worked fine, because I don't know, I couldn't figure it out by just reading the book. I mean, how a data discovery solution would work for data catalogs.
Yeah. So what I'll say about that is like up until the last like maybe 3 or 4 years, data catalogs were a pretty manual process where teams had to actually go in and write the documentation themselves about like, okay, this data source is feeding this data source relates to the marketing analytics team. We can trust it, like we validated it. Like it was a very manual and kind of resource intensive approach to actually maintaining a data catalog. But recently there've been a lot of solutions and a lot of developments in knowledge graphs and kind of AI and ML that have enabled kind of the aggregation of metadata. So metadata is data about your data through traces, logs, and other means to kind of put together a holistic map of your data environment. So it's how sources connect to each other. Like for instance, how your table in Snowflake maps to the downstream dashboards and Looker or Tableau or whatever you're using. And so data discovery is a way of understanding the relationships between between data and data assets and data sources and your environment and how they evolve over time. So it's really just kind of a way of applying machine learning to your existing data cataloging approach through knowledge graphs, through SQL parsing, through the aggregation of metadata, and kind of these other more novel approaches. And there's really cool vendors and companies that are doing interesting things in this space. And building one yourself is a little more complicated. You would need to develop like a homegrown SQL parser. You would need to do a lot of kind of the upfront work yourself. But it's definitely doable, and something that we did at Uber. We actually had our own kind of like a data discovery enabled data catalog called Databook. And it was used by disparate teams at the company. And I think there was like a team of like 10 who were managing it at any given time. So as I said, it can be a very manual process, just because if you have like a Snowflake data warehouse and like a couple Looker instances, and you don't have much going on in the way of like transformation and modeling, it's probably not going to be that hard. But as your data pipelines get more and more mature, and you add in more DBT models and Airflow or orchestration, and you do more complicated things with the data, and there are more eyeballs on the data, and it just kind of takes a lot of time and resources. And so that's where something like data discovery comes in. So to answer your question more simplistically, I would say data discovery is just kind of the ability to search for and understand your data and the relationship between data. And Lineage is a tool to enable data discovery, certainly, as well as other forms of knowledge graphs. And a lot of data cataloging solutions nowadays will incorporate some element of data discovery. Some of them you can even search for like a specific data asset, and it can take you to where that lives in your environment. Does that answer your question?
Yeah, I think so. Maybe the lineage is the input, so you can use AI and generate text.
Yeah, I would say lineage is the lineage is the technology to enable data discovery. Data discovery is kind of an outcome.
Okay, yeah, and you can get not only the lineage but also logs and other stuff to build that with AI. Okay,
exactly.
It makes more sense to me now. It makes a lot of sense. Thank you.
Good.
On the same topic, I have a question about the data lineage with like different AI technologies. Like before we have the SQL parser, I mean, you mentioned the SQL parser, but a lot of the data pipeline is built on Python or even other languages, not SQL. Like how are we going to do about that? Like there are a lot of Airflow jobs, for example, could transform data, do ETL in Python entirely.
Yeah, that's a good question. So that's where you might use like an open source solution like PySpark, or I mentioned there's actually one that we built for this very purpose called Monte Carlo, which is just kind of like a way where you can it's for our solution specifically, but it's a way where you can use Python to build kind of to map the relationships between different sources. And there's actually Databricks is building a lot of kind of these open source tools, like Unity Catalog is an open source solution that works with PySpark and other things to kind of basically take go beyond the limitations of SQL when you're putting together lineage graphs and other kind of forms of documentation about your data ecosystem. And so I would say that for folks who are building lineage themselves, to go beyond kind of like the SQL parser, I would consider using one of those kind of open source frameworks. And we list several in the book. And my colleague Ryan Kearns is the one who actually wrote that chapter. So he would be a great person to reach out to provide kind of guidance there. But there are definitely several frameworks and APIs that can kind of make go beyond SQL if you're trying to integrate ML models in your lineage graphs, which is something that that we've done at Monte Carlo with PySpark.
That's so good to know. Thank you. So good to
Yeah,
know it's
I
not
would.
just
Ryan
SQL.
Ryan. Yeah, no, not just SQL. You could definitely use Python and other frameworks. Ryan Kearns, and I can share his information later, but he's definitely the person to talk to who is really really instrumental in this chapter in the book.
Awesome. Thank you. So I want to learn a little more about Monte Carlo, if that's okay.
Yeah, of course.
So from my understanding, it's a data discoverability, data observability tool. So the main technology, is it the SQL parser, the Python parser to provide the data lineage, and also provide the anomaly detection on top of that? Is that about right?
Yeah, so Monte Carlo is a data observability platform, and we leverage kind of a proprietary SQL parser and a data connector that aggregates metadata, so logs, traces, all that good stuff, to kind of put together a holistic picture of what data health looks like for your organization, so that we can trigger and send alerts to your data team when there are anomalies or changes or your pipelines break. And one tool that we have within the platform is field level lineage. And so that's where our SQL parser comes in. We also used Antler to build our Antler is like an open source kind of graphing tool to build our lineage graphs. There's a few other things that we use to build it, and it's outlined in the book. And I didn't build it, but several folks on my team who contributed to that chapter were responsible for it. So yeah, so how we do that is kind of like a proprietary SQL parser and data collector that we've built actually on top of Snowflake and Databricks, and a lot of really kind of hot data tooling. And so what we do is we put together a holistic picture end to end, from ingestion in the warehouse or lake all the way down to the BI layer of what your data looks like at any given point in time, and give you the tools to fix data issues as they arise.
Speaking of the BI layer, like there could be a lot of BI tools. Are you all connected
100%.
to all of those tools?
100%. We integrate with all of the major data stack tools. So Tableau, Looker, Mode, Power BI is an integration we announced recently on kind of the warehousing side. Databricks, Snowflake, GCP, Redshift, all the kind of cloud native warehouses and lakes. And then we also integrate with DBT Cloud, Airflow, Prefect, and kind of all of the modeling and orchestration tools too. So it really gives you a holistic look at where the errors occurred and how to solve them.
That's amazing.
That's the beauty of the modern data stack, right? Everything with everything. It's awesome. Yeah.
100%. Yeah.
Daniel, do you have other questions?
No, Sophia.
No? Okay. I think I asked my questions too. Anything else you would like to share with us? I feel like I've learned so much from just communicating, chatting with you. Just gives me more context about the book. Like, yeah, absolutely. Connecting dots together.
I would say if anyone has, sorry, continue.
Well, yeah, just an observation. I think it's incredible that O'Reilly guys went to you and asked for that book. Usually it's kind of the opposite, right? The authors go there with a plan and it has to be approved. So yeah, it is a statement to the great work that you guys are doing.
I mean, I think it's a testament to the seriousness and criticality of this problem, and how data quality, to your point earlier, Daniel, really does not get the respect it deserves. And the fact that it touches so many different teams, from data engineers to analysts and data scientists, all the way, down the pipeline to the folks that are consuming the data, operations teams, marketing teams, sales teams. Like, data quality is a problem that affects everyone. And unfortunately or fortunately, it's really kind of up to the data team to solve the problem and make sure that the data is reliable. And I think often they kind of get the short end of the stick. I have a lot of friends who are on data teams and are analysts and analytics engineers, and they're kind of glorified SQL kings and queens, where they're asked to like query things and surface insights and fix problems, but they don't get the credit they deserve for being the ones to really provide the competitive advantage for their companies. So we really wanted to create something that could be used as a resource and help them solve this very real problem of data downtime, so that they can spend their time focusing on what matters and what actually gives them what they want to do and enjoy doing, which is creating these really interesting analyses and insights and all that good stuff. So the book is called Data Quality Fundamentals. You can order it on Amazon. If you do read it, please review it. And if you have any questions about the material, feel free to reach out to me. You can find me on LinkedIn. I have a pretty unique last name. There's not many other Vorwerks out there. Or you can just send a note over email, and I can share my information after the chat.
Yes, awesome. Thank you so much. And the book is also free on the
Yes.
Monte Carlo website.
Yep, all you have to do is search Data Quality Fundamentals Monte Carlo, and you can get a free copy of the book.
Yes, please go get the book. It's quite nice. And I really appreciate it's not a sales book. You don't have sales pitching there.
No, we do not. Yeah, we're really adamant about helping folks solve this problem. And so we talk about all sorts of technologies and mention all sorts of elements of the modern data stack. And so really hope folks find it valuable.
Awesome. Thank you so much, Molly, for chatting with us today on a Friday afternoon. Hope you have a great weekend, and thank you. The video will be up soon, and I will send you the link when it's up.
Sounds good. Thank you so much, Daniel and Sophia. Have a great weekend.
Thank you too.
Thank you.
Bye.